Hello, my name is Kendall Powell, and my presentation is over how heat energy can be used to power the world. A little introduction. Heat, or thermal energy, is the result of the movement of atoms, and it can be transferred from one object to another. Heat energy is also a low-grade energy, and that means when it attempts to transfer heat back into other forms of energy, it is very costly and ineffective. So there are some ways that heat energy that can power the world that are a little more effective, such as solar energy, geothermal energy, biomass, and fossil fuels. And then a way of converting wasted heat energy from all of those things that power the world already is thermoelectrics. So why is thermal or heat energy so important to us? Well, for one, obviously, it provides us with heat, and that has a lot to do with keeping us warm, heating houses, heating buildings, whatever it may be, cooking, heating food and water. That's very important for human survival, both of those things. And then making important resources, textiles, almost all of the things that we use today were made with thermal energy. So without thermal energy, we would not have the advanced way of life that we do today. There is an equation for thermal energy, and it is shown on the screen. It is thermal energy equals the mass of the object times the specific heat times the change in temperature. And this will show the heat energy being transferred will cause a temperature change. That's that equation in simple terms. Another important aspect of thermal energy is there are three ways that it can be transferred. We have conduction, which is the transfer of heat when two objects are directly touching, and that is thermoelectrics, which we will get into that later. There is convection, that is the transfer of heat through a fluid, and that is involved with harnessing the solar energy and geothermal energy. And radiation. Radiation is the transfer of heat without any physical contact between the objects. This applies to the burning of biomass and fossil fuels, which we will get into later. Alright, the heat energy sources that are used commonly today and every day are solar energy, geothermal energy, biomass, and fossil fuels. Let's talk about what they do. Let's start with solar energy. Solar energy is from the sun, and it is the most abundant energy source on the planet. Some ways to harness the energy from the sun is with solar panels, but this harnesses sunlight. A way to harness the heat energy from the sun is through solar thermal, and the sunlight will heat up a liquid that's in a pipe, and the pipe will bring the heated liquid up to a turbine that will eventually produce electricity. Also, sunlight can be used in thermoelectrics. Next is geothermal energy. Geothermal energy is what is underneath the Earth's surface in form of molten rocks. So there is a lot of heat coming off of those molten rocks in the core of the Earth. So how do we harness that? Well, we send liquid down into the core and to come into contact with that molten rock, and the hot liquid will be extracted back to the surface, and it will power a turbine for electricity. Very similar to solar energy, just a little bit deeper. There's a picture that illustrates it. Another form of heat energy that we can harness to power the world is biomass. Biomass is the organic material that comes from plants and animals. How we harness the energy, or where the energy comes from, is the burning of the biomass. So we can burn wood to heat buildings and generate electricity. We can burn agricultural crops to make fuel. We can burn food, yard, and wood waste, and this can generate electricity, and it can make biogas, which can be used in many other things, and it's more environmentally friendly. And we can burn animal and human sewage, and this creates biogas as well that can be burned as fuel. Lastly, we have fossil fuels. Fossil fuels is the decay of old plants and animals underneath the surface of the earth. So this is a non-renewable energy source, and it is not as environmentally friendly as the others. So it would be very smart for us to move away from this because it is damaging our climate and atmosphere, and these other forms of heat energy to power the world are much more effective, and so will thermoelectrics, which we will talk about in a second. So examples of fossil fuels is coal. Coal can be burned to generate electricity and to power thermal power plants, such as like the steel industry. Coal is used a lot. Also, oil. Oil you put in your car. You get that from fossil fuels, and almost everyone knows that like burning the oil is not very good for the environment. So we need to move away from that. All of these are common ways thermal energy can be converted to power the world, but new technology is being utilized to produce cleaner energy from the excess thermal energy of these processes. Thermoelectrics. I keep mentioning thermoelectrics, but what does that mean? Thermoelectrics is a way to harness wasted heat energy from machines and industrial processes, electrical equipment, and even the human body. So it is a two-way process. It's called the Peltier and Seebeck effect. One of the processes is temperature difference creates an electrical current, and this is called the Seebeck effect. And there's another way it can process, which is the electrical current can create a temperature difference, which is the Peltier effect. A very important thing about thermoelectrics is that the material needs to be good at conducting electricity, but not thermal energy. Let's talk more about these individual processes. So, the Peltier effect. This is when the cooling of one junction and the heating of another can from an electrical current. So Peltier determined that this is linearly dependent and it is thermodynamically reversible, which is very important. And his effect has applications in cooling and heating, and they are efficient temperature controllers. The Seebeck effect is the one that is more directly related to the way thermoelectrics work, because that is harnessing temperature to create an electrical current. So the Seebeck effect is the production of an electrical current when at least two dissimilar conductors are maintained at different temperatures. So there is a temperature gradient. And the Seebeck effect actually has a coefficient, and this is the connection parameter between the input temperature difference and the output voltage difference. So there it is on the screen. Delta V is the voltage difference, delta T is the temperature difference, and the negative sign stems from the negative charge of an electron and the way that it moves throughout the generator. So how can thermoelectrics be used to harness wasted heat energy to power the world, and how is it being used? There are already some on automobiles, spacecrafts, industrial and residential buildings, and even the human body. It is very important to, at least for the first three, it is very important to try to convert this wasted heat energy, because most of these wasted heat energy is negatively impacting the environment. So with automobiles, they have an inefficient internal combustion engine. And a thermoelectric generator can be placed on the exhaust and the radiators, and hopefully it can capture and convert enough of the wasted heat energy to power some of the electrical aspects of the car. Next, spacecrafts. So in space, solar panels aren't that efficient because there's not enough sunlight or direct sunlight. But thermoelectric generators can pick up the radioactive decay of plutonium-238, and this can help power some part of the spacecraft. Next, industrial and residential buildings. There's a lot of wasted heat energy from industrial buildings, and that heat energy can be reconverted to power a small generator or something inside of that building. Same with residential homes or buildings. Laundry machines, stove, oven, dishwashers, those let off a lot more heat energy than we think, and it could be helpful to try to convert that into electricity. Also, the human body. They've created a watch that can power itself from the heat energy released from the human body. Thermoelectrics is really important because it could potentially lower the cost of electricity bills if we are able to harness the thermal energy let off by common appliances in our life to create electricity rather than having to have it brought in at all times. Thank you for listening, and I hope you learned something about how we can harness heat energy to power the world.